Well, good afternoon. We are here with an iConnect panel discussion, and we're going to talk about cleaning of electronics assemblies. So the reason we're doing that, many of you used to use or do use no-clean, but because of new requirements for reliability and miniaturization and more population on the board, we now have to do more cleaning. So today I'd like to introduce our panel. Sitting directly next to me, to my left, is Rob Lee with DuPont, and he will concentrate on solvent, organic solvent aspects of cleaning, although you're free to jump in and talk, any of you, about anything you want. Next is Mike Conrad of Aqueous Technologies. He's going to talk about aqueous cleaning. And then finally, you would think you have aqueous and solvent. Well, representing everything else is Keith Swan, Crystal Mark, and he will concentrate on abrasive cleaning as one of the non-chemical cleaning. So to begin with, I'd like to start with the concept of challenges. What new cleaning challenges do you see for today's electronics assemblers? Let's start with Mike.
Well, Barbara, I wouldn't say they're new. They're continuing, and they're continuing at a faster pace, and they present a greater challenge. To us, there's two issues. One is cleaning under low standoff components.
Yes.
The people who invent these components and think that 1 mil is plenty of space and worry about cleaning later always present, I think, everyone at this table with a challenge. The other challenge is the environmental aspect of cleaning, is making sure that we don't solve one problem without creating a new set of problems.
Sure.
And that's effluent management and things like that. So getting everywhere under component and not ruining the world while we're doing it is always a challenge.
You want everything.
Yes.
Yes, so do I. So, Keith, would you like to add to that, build on it?
Challenges. The challenges that I see mostly are coming up with a type of abrasive that is selective to what you're trying to clean and is not destructive to the board that's there.
Well, that's a really good point. I think the materials compatibility is important for many sorts of cleaning. And then, basically, Rob.
Well, I think the challenges that we're seeing are sort of a continuation of the challenges that have been occurring over the last several decades. The components getting smaller and smaller, so it's getting harder and harder to clean those assemblies. But probably in the last couple of years, another aspect has come up, and that is in the area of environmental regulations. We've seen a significant step change in the amount of regulations that are coming into play. In particular, there's some vestiges of the old Montreal Protocol that are finally kicking into gear this year. And so we have a lot of folks who are looking to convert away from those chemicals to other chemicals that are more environmentally friendly. So in addition to the normal challenges, if you can call them normal, so to speak, there's also the environmental regulations that folks are starting to see.
Sure, and you were alluding to HCFC 225.
That's correct.
Which people have had about 25 years to think about, and now with half a year left, they're saying, ooh.
Well,
yes.
Absolutely.
So, there has been a historical feud between aqueous cleaning and solvent cleaning, and then there's non-chemical cleaning, which is its own world, shall we say, and yet is going to be there. Where would you say are some applications where non-chemical cleaning would be particularly desirable?
Non-chemical cleaning
Meaning,
it's going to be desirable where you have debris that's on a board or on a circuit that can't be dissolved with either aqueous or chemical, or where the combined nature of the two substances is very difficult to get rid of. both environmentally or chemically hazardous. But that being said, I think that my technology actually relies on both chemical and aqueous solutions in post. So when you clean something with an abrasive method, you have to actually clean it twice. You're cleaning it once to get off the debris that you're going after, but then we're introducing a certain amount of debris to whatever it is, and that has to be cleaned as well.
Sure.
So we try with electronics, we try to work with water-soluble or chemically soluble compounds so that they can either be batch or inline washed.
That's a great idea, so it integrates.
Right.
Yeah. Okay. Rob, would you like to discuss organic solvent cleaning and a few of the advantages?
Well, yes, the organic solvents, the advantages are the fact that they have very low surface tension, and when the solvent dries, it leaves a very clean part on the surface.
Yes.
So there is no residue left over, and that's a very important advantage for solvent cleaning, is the fact that it's no residue left over after it evaporates.
Yes.
Whereas in other types of cleaning, there's quite a bit of rinsing and washing that needs to occur afterwards, and of course the drying.
Absolutely.
And in particular in the western states, water is becoming a very precious commodity. So we're starting to see customers look at solvent cleaning as a way to conserve water and to minimize their amount of water. So that's that's an advantage for solvent cleaning.
As a California girl, you know what I forgot to do? I don't think I introduced myself, did I?
No, you didn't.
I didn't.
Who are you, Barbara?
Who am I? We all wonder, and I'll let you speak. I am your moderator and facilitator. I am Barbara Koenigsberg, BFK Solutions, and I am known as the cleaning lady. I consult in cleaning, helping people to develop cleaning processes. So, didn't mean to interrupt you. We'll move right on to you, Mike, in terms of aqueous.
Well, one comment first, Barbara, on the intro you made to this question, which was the feud between solvent and aqueous.
You don't think so?
No, not at all. I think it's just a swap in market share. There are valid applications for each, and there are unique attributes and disadvantages of each technology. Prior to the Montreal Protocol, I would estimate that about 80 to 90% of the market share was in some type of solvent. Mm-hmm. After the Montreal Protocol, well after, today, 20 plus years after the Montreal Protocol, I think the percentages have reversed. The IPC cleaning handbook, 65B, talks about aqueous cleaning as the most common form of cleaning electronic assemblies. And we're routinely faced with dilemmas where certain parts, unsealed potentiometers, switches, relays, can't come into contact with water because water can get in and can't get out. So we refer them to our solvent friends routinely for that application.
That's really cool because I think we need to have spirited discussions, but also things need to mesh harmoniously, and certainly we have clients who use both aqueous and solvent, sometimes for the same assemblies. Yes.
Well, and also whenever a particular type of technology becomes dominant, advances pick up at a faster pace in that technology as companies try and compete for a larger share of that larger share market. And when it comes to cleaning now, cleaning has become, at least in the aqueous world, and probably other worlds too, well beyond removing contaminant species from a target assembly. It's cleaning, and at the same time, cleanliness testing, it's data management systems, chemical management systems, effluent management systems, and we have to take stuff off boards. So it becomes far more than just the removal. And one last point, in the glory days, the heydays of solvent cleaning, before the Montreal Protocol, there was really very little, well, first of all, almost everybody cleaned, and there was very little technology behind it. The technology lived in the chemical, particularly from DuPont. Freon TMS was a wonderful solvent. It would be today.
About Freon I remember.
Exactly.
That. Absolutely.
Put it in, count to 30, pull it out slowly so you don't lose it all. It's dry and it's clean. But then when the early aqueous chemicals came out, the phase 2, the IPC phase 2 testing, wanted to determine if they're at least as good as the solvents. And almost all of them were rated out of a possible worse than, equal to, or better than. Almost all of them scored better than. It's
Well,
a longer
you know,
process, but it's usually
you're right.
cleaner.
You're right. And in fact, now the requirements have changed. So certainly what we did then is not what we're going to need to do tomorrow. And since people are now, because of miniaturization, are making changes in various directions, we're beginning to test new cleaning processes. And I think you were right to mention the process. Wouldn't you say that it's a process?
Oh, absolutely.
Absolutely. And so when we're looking at a process, how would you go about testing? If you were an electronics assembler, other than buying a lot of chemicals from you, how would you go about testing? How would you go about investing in cleaning equipment, new chemicals? What would you look for in a partner?
Yeah, I mean, I kind of look at it as really it's aqueous and solvent. We kind of go hand in hand, so to speak. The end user is really going to look at their process and decide, which one is good for them. Because ultimately, in this day and age, the solvent people, we can, create a lot of noise. Hey, we're better. The aqueous people can do that too. But in the age of Google, all that information is out there in front of people, and they'll make, their decisions. So it's best for their for their process.
Oh, yes.
And in terms of how to measure the cleanliness, I think it's really changing. I mean, when I talk to customers, what I find is everyone's different. And in fact, the other day I was talking to a large aerospace and defense contractor, and they were still using 111 of all things.
Oh, sure.
And
it's still around.
It's still out there.
It's out there. It's working, isn't it?
And I was chatting with them about their specifications, and they didn't have any specifications.
No, it's because
really,
great-grandma used 111 trichloroethane, which is
that's
another
exactly
ozone-depleting chemical.
That's exactly right.
So people, I think you're saying that people need to look at some of their assumptions. And absolutely. Let me move on to you, Keith, because you're in working with abrasive blast. How would you suggest that people go about testing new processes?
Well, in my shop, we do a lot of trial and error with it.
We do too.
Quite literally.
Yeah.
I mean, for our equipment and our process, I typically have somebody send a sample of a product into me,
Yeah.
and I'll do, with their specifications, what they want removed, and we'll do our best to remove it. And again, we try and find a compound that will remove the debris, but preserve the product.
Yes.
And if we can find one that's either water or chemical soluble, that's great, because then we can get it off. Otherwise, we're left with dry methods of removal, ionized air,
Sure.
or that's about it.
Well, I know that you mentioned not needing to dry. Advisedly, sometimes chemicals leave a residue, and sometimes solvents will outgas. So really, we have to customize the process for the manufacturer. Let's see, I'm ignoring you for a minute, but do you mind if I ask just for a second, Rob, how you deal with outgassing with residue?
Yeah, that's a very good question. And typically in a vapor degreaser type process, you need to look at the compatibility of the components with the solvent, because you do run the chance that some of the elastomers may actually absorb the solvent.
Yes.
And then when you think the part's dry, it actually is desorbing off of the surface after it's been cleaned. So what we do in our lab is, we run a cleaning trial, and then we actually look for any outgassing after cleaning.
Okay.
So we do a pretty strenuous process after cleaning.
Sure.
But in general, what we find is that the elastomers are pretty compatible with our solvents.
Okay.
So we don't necessarily see that as a problem every day, but it's definitely something that we keep an eye out for.
Well, you did discuss materials compatibility, and that is important. I have run into situations, I don't know if you folks have, where people have specified cleaning equipment, And then they specify the cleaning agent, and they've never quite tested them together. And they've spent hundreds of thousands of dollars only to find that, say, the frequency of the ultrasonics is damaging the part. How do you avoid materials compatibility issues, Mike?
Do you mind if I go back to the prior question and finish that off? Is that okay?
No.
No, you don't mind?
I don't mind at all. Do you want to?
Going back to, just one more thing, going back to how do we know if it's, to paraphrase it, how do we know if it's clean enough?
Sure.
The problem is there are standards which are incredibly obsolete. They were designed in the 70s,
Yes.
well before even surface mount was surface mount. And I think the amount of, there's residue that can be on a board doesn't mean it's bad. There's a tolerable residue and intolerable residue. So the amount of tolerable residue is quite different. Say for example, a Cisco router board that's going to be in a server farm in a temperature humidity controlled environment versus a aileron control assembly in an unpressurized part of an aircraft that's going to go from minus 60 to plus 112 within an hour, several times a day. So the amount of tolerable residue varies from assembly to assembly. How do we go about proving that we are, the original question, that the boards, what level of cleanliness we should strive for, varies from bulk ionic testing to ion chromatography results. The best method, in my opinion, which very few people will do, is to accelerate the age of the board through steam age testing, undercurrent power, see if you can get electrical chemical migration, see if you can get parasitic leakage, and age that board several years in a short period of time.
Sure.
And that will establish how much residue is tolerable versus how much residue is not tolerable. Because clearly 0.0 would be ideal for every assembly, although not necessarily required for every assembly. So
Yes,
that was the former question. If you can remind me what the latter question was.
What was, how do you help people, or how do you help people
Material
avoid,
compatibility.
well, basically it's a matter of coordinating the chemistry and the equipment and making sure that you don't purchase incorrect.
Yeah. The chemistry, the equipment, and the target are both the triangle there. How do we do it? We make sure that we specify from our material partners, our chemistry partners, material compatibility sheets to make sure that the material is compatible with certain elastomers, all the materials that are used in the machine. Second, there's a process compatibility. Water-based chemicals, if not properly formulated, could foam. You know, do we produce too much energy and create big foam blobs? Odor is a question, because if an operator smells something, it is always bad. It doesn't matter what they smell, it is always bad, and it creates mass hysteria. Yeah. So compatibility with the machine, compatibility with the target, and with the operator are all important factors. Testing, due diligence is what's required.
Yeah, we often find, Barbara, that it's almost every application is different, every customer is different. So we bring the parts into our lab and we clean it, and we spend quite a bit of time tinkering with the part to try and get it clean to find the right process. And I'm sure that's what you all do too. Yeah. And,
well, and don't you find, all of you, that sometimes compatibility charts provide an indication, but when you get it into the process, when you combine it with the force, the temperature, the time, you could have a whole different ballgame. Yeah.
Each one of those elastomers, like for example, you might get an elastomer that is a urethane or something like that, and the compatibility chart might say you're compatible, but there's a tremendous number of grades.
Yes.
And
absolutely.
So you don't know whether the manufacturer of the elastomer put it in this plasticizer or that plasticizer, how much of that plastic, you just don't know. So it really turns into that chart is really a guideline. But
I think that's
ultimately,
important.
You have to run the test yourself.
Now, Keith, would you like to discuss compatibility a little bit, because it's non-chemical cleaning, but not quite. You still have the abrasive and the material and the force.
Right.
You don't want to take the parts off the part.
Right. You don't want to take the parts off the board. Well, basically, abrasive is probably going to be the last step for somebody who has a problem
Okay.
with cleaning. They're going to avoid abrasive process if they can. They're going to go with either an aqueous or a chemical, or even a plasma etch before they try using an abrasive process. With an abrasive process, there's undoubtedly you're going to be introducing a certain amount of particulate to the board of the abrasive. As such, when there are situations where aqueous and chemical and plasma etch fail, that's when they're going to start using
It's a good point.
an abrasive process.
Now-
and then they're going to use one of those to follow it up to scavenge whatever's on the board off.
Of course, sometimes, and it's interesting, plasma etch is considered non-chemical cleaning. Since there's no plasma person here, I guess I'll talk about plasma for a second. It's actually a lot of different chemicals that are generated in situ, either often right in a chamber. So you have all kinds of free radicals and all sorts of interesting things going on, and you can have a lot of surface damage, or depending on the way you use it.
Yeah.
So I guess it all needs to be treated in a manner that's specific to the process and with a great deal of respect. And I think on that note, if would anyone like to say, that's all, folks? I think we've covered quite a bit in a short time.
Well, I'll say one other thing. Both
Go
these
ahead.
gentlemen have very good points that they make, in that there are a lot of different materials that are out there.
Yeah.
And any circuit board, there's literally millions of combinations of materials. And so the only way to really figure out what's going to work is by testing. And so, Mark is suggesting aging the boards, and you're talking about different solvent methods, which solvents work on which materials, and the same thing applies with the abrasive method. So,
Sure.
and it's going to be probably a combination of all of those things that come to a perfect solution.
Sure. And I agree with you, the aging is terrific, and sometimes if it's in a real critical environment, like if there's anything in a hospital environment, you might actually have to, or where it's a critical high-value product, you might actually have to do a little surface analysis to see what's left on there too. Do you want to?
Well, yeah, I think as the diversity of electronic parts expand, the cleaning solutions are going to become more and more diverse. The cleaning challenges are going to be more and more diverse because the parts themselves are becoming more diverse. And I think it's just the age that we live in.
I think you're right.
Nothing is cookie cutter anymore. It's just becoming extremely diverse.
Yep.
And so I actually think that the challenges are going to be continuing to grow, and
I agree.
perhaps at an exponential rate, because there's so much diversity now in terms of the parts.
Quick last word from Mike, because I think the challenges are going to make things fun.
Yeah, what's interesting is, we started off talking about feuds between technologies. I think what we all, and there really aren't any, I think what we're all saying, or the direction this industry is going, is that whether solvent cleaning is the most appropriate, or water-based cleaning, or abrasive cleaning is the most appropriate, the end game is cleaning adds reliability. And regardless of what mechanism or media is used to take the contaminant off, contaminants cause problems, more problems today than they caused 20 years ago. I guess they will cause more problems 20 years from now than they cause today, as miniaturization continues down its path, as reliability expectations only rise, and as clock speeds and frequencies on boards increase.
Absolutely.
The amount of residue that's tolerable is shrinking. I think cleaning is like a shadow slowly casting itself back over the cleaning industry. You mentioned earlier about no clean flux, and it used to be, well, you either clean or you use no clean. 80% of our customers, and I reckon a similar percentage of yours, are removing no clean fluxes. No clean is our friend. They're a partner, because most of the no cleans are now being removed. And
I am
it's an
old
irony.
enough to remember when there was a great argument about calling no clean fluxes no clean. The correct term should
Low
probably
residue. Exactly.
Yes, stole my punchline. You're right.
We sing from the same hymn book,
La la.
It should not be called no clean. People read no clean as an instruction manual. It's not. It's low residue, which may mean no clean. It may mean clean. But how can a jar say no clean when they don't know where the paste is going? Is it going on the Hubble telescope? Is it going into a Nintendo video game? The word no clean is very subjective.
But I think we're actually on a little bit different pages, but we're all on the same goal: achieving better reliability, higher productivity. And I guess, as Barbara, the cleaning lady and moderator, I will thank you all for being here and for this really informative discussion.
Thanks, Barbara.
I want to thank you, Barbara.
Thank you.